So we've been talking about arithmetic sequences, which are just basically a list of numbers. But I want to mention something now called an arithmetic series. And a series is closely related. Series just means that you take the sequence of numbers and you add them together. So simple example, suppose you had 1, 2, 3, 4. And then if I went like this, if I went 1 plus 2 plus 3 plus 4, this right here is the series. And this right here is the sequence from which the series came. So that's the main difference. What we want to do in this section is talk about how to find the sum of a series, how to add them together, and then also how to find the number of terms if they started out by giving us the sum. So before we talk about any of that, I want to tell you kind of a famous story in the history of math about a famous mathematician. His name was Carl Friedrich Gauss. And the story goes like this. Gauss was, if you had to make like a Mount Rushmore of mathematicians, Gauss would probably be on that mountain. He was, I don't know if you want to say he was the Michael Jordan of math or the Babe Ruth of math, whatever analogy would be, but he was definitely a huge contributor. So here's the story. He was 7 years old. Different versions of the story have different kind of details, but the version that I've heard was that he was 7 years old and his teacher wanted to keep the class busy. So he told the students, he said, "Class, I want you to sit down and I want you to add all the numbers from 1 to 100. So 1 plus 2 plus 3 all the way to 100. And I guess the story goes that the teacher wanted to take a nap. He was tired and he thought this will keep him busy for hours and hours. So Gauss sat down and probably about 1 to 2 minutes later he stood up and he said, "I have the answer." And he gave it to the teacher and the teacher checked it and it was right. So you're probably amazed by that story if you really think about it. How could a 7-year-old add all the numbers from 1 to 100 in under 2 minutes? But the amazing thing about it was Gauss discovered a way to do this very easily. He didn't actually do 1 plus 2 plus 3 plus 4. He used a much easier method to find the answer. I'm going to show you how he did it right now. So he said this. He said, well, let me line up the numbers like this. Let me do 1 plus 100, and then let me do 2 plus 99, and 3 plus 98. It doesn't really matter what order we add them, so I can do it this way if I want to. And I'll go all the way down to 50 plus 51. So 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. Okay, and every single one of these are going to be 101. So the question is, how many pairs of 101s will there be? And if there are 100 numbers, there will be 50 pairs, because 50 times a pair is 2. 50 times 2 is 100 numbers. So 50 times 101, well, that's not hard to do. That's 5,050. That's how you get the answer. So that formula that he used, we didn't have maybe the formally written formula. That formula that he used is basically this one right here. There are two formulas to add sequences of numbers, to add a series, I should say, and that's one of them. This right here means the first term. So in Gauss's example, the first number was 100. This right here means the last term. So I'm just going to write these first and last term. The last term in his sequence was 100. So 1 plus 100 is 101. And then n was the number of terms. He had 100 terms, but he split them into pairs. So that's why we have n over 2, 100 over 2, which is 50. And 50 times 101 gives us that number right there. So there's two formulas you can use. This right here, and by the way, the S sub n means the sum of that series, the sum of the n terms. In this case, n was 100. You use this first formula if you know the first term, the last term, and the number of terms, because that's what they're giving us here. N is the number of terms. A sub 1 is the first term, A sub n is the last term. So that's the formula you would use if you know those three things. If you don't know these three things, you could use this one instead. If you know the number of terms, let's say you don't know the last term, but you do know the common difference. That's what D is. And again, you know the number of terms and you know the first term. Now you might ask yourself, why are these the same? Why would you get the same answer? And here's why. You might remember from before, from an earlier video, that we have a formula for the nth term. I'm just going to write it over here. Our formula for the nth term was this. It was take the first term, add the common difference times 1 less than the number of terms. So we can go to this formula right here and we could make a substitution. We could say, suppose that we went a sub 1 plus, and now instead of writing a sub n right here, I'm going to take a sub n, I'm going to take this thing and just substitute it right in, as you see right there. And when you do this, a sub 1 plus a sub 1 is 2a sub 1, and there is the other version of that formula. Okay, so it should be an n over 2 right there. Okay, if you go back to what we had before, take a look at that formula right there. That is the second formula that we have in red right here. It's right there. So we'll use those two formulas to try to see if we can find the sum of these series right here. And again, we get to choose which one we use based on the information that they give to us. So we want to find the sum of each one of these series. I'm going to keep those formulas up there so we can refer to them. All right, so in the first case, we have the first and last term and the number of terms. Well, this one should be kind of a layup. There's the first term, there's the last term, there's the number of terms. So we definitely want to use this first one right here. So the sum of, I'm plugging in 12 for n because they're telling us n is 12. That's going to equal the number of terms, 12, over 2, because we can make 6 pairs of terms, just like when Gauss's example, we had 50 pairs. The first term here is negative 4, plus the last term is negative 81. All we're doing is plugging numbers into these formula that you see up here. 12 over 2 is 6, negative 4 plus negative 81 is negative 85, and you multiply those to get negative 510, and that's actually the answer. If you were to do negative 4 plus whatever the next thing is plus whatever the next thing is all the way out to negative 81 in that series, if you were to add all those together, you get negative 510, but the way that we just did it is obviously a much faster example, so that is the better way to go. Number 2, which formula to use? Well, they're giving us the first term, the difference, and the number of terms. Here's the first term, here's the difference, here's the number of terms. It would make most sense to use that one right there. So we are being asked to add the first 40 terms of this series with 13 plus, and then the difference is 9. So the next term would be 22, because I'm adding 9 to 13. Next term would be 31, next term would be 40, and we want to add the first 40 terms. You could do it the hard way by actually listing out all 30 terms and adding them, but it's much easier to plug these numbers in. So n over 2 right here is 40 over 2, and then we have this big parentheses here. 2 times a sub 1 would be 2 times, this is a sub 1, so 2 times 13, plus the common difference is 9, and then n minus 1 is going to be 40 minus 1. So now we can simplify. So 40 over 2 is 20, 2 times 13, 26, 9 times, this is 39 right here, 9 times 39 is 351. So we have 20 times 26 plus 351 is 377, and when you do 20 times 377, what's that? 754, I think 7,540. That's what this is. That's the sum of the first 40 terms, which is what S sub 40 stands for, sum of the first 40 terms. Alright, so now let's try these other two down here as well. I'm just going to move those formulas down so we can see them. See if you can pause the video and try these two on your own. Number 4 is definitely more of a challenge, but I think you can do it. So this one here we have, what do we have? Well, we have the first term, but that's used in both formulas. We have the number of terms, that's also used in both formulas. They don't give us the last term, so we need the last term for this one. They also don't give us the common difference. However, it would be easy to find the common difference because they're listing out a bunch of terms. So what did we do to get from negative 29 to negative 38? We subtracted 9, and we subtracted 9 again. So we just found the common difference. So that what that shows is that sometimes you need to, I'll just put this over here to rewrite it. Sometimes you need to find maybe 1 or 2 extra things in order to be able to use or be able to determine which formula you need to use. But in this case, it was easy to find the common difference, so that's what we use. So we're being asked to find the sum of the first 15 terms, because n is 15. That's going to be 15 terms over 2, and then 2 times a sub 1. The first term is a sub 1, that's negative 29. The common difference we found out is negative 9, and then n is, in this case, n is 15, so n minus 1 would be 15 minus 1. And now we just need to simplify. So 15 over 2. 2 times negative 29 would be negative 58. And then over on the other side we have 15 minus 1 is, that's 14. So we have negative 9 times 14 is negative 126. Negative 58 minus 126 is negative 184. And then 15 times 2. 2 goes into itself once, and it goes into that negative 92 times. And then 92 times 15, I believe that's 1,300, negative 1,380. Not certain about that because I don't have a calculator with me, but wouldn't be hard to check. So that is the sum of that series right there. Let's try this last one, which is more of a challenge. So number 4. So number 4, let's see what they're giving us here. They're giving us, I'm just going to move this over here, and then let's just erase this, and we'll put a dividing line so we don't get those two formulas mixed up. So what are they giving us here? They're giving us A1. They're giving us the last term as well. They're not giving us the number of terms though. So if they were given the number of terms, we could use this one. Actually, we need the number of terms for both of these. So the problem is, it seems like we don't have enough information to use either. But I think it would probably be easier to use the first one, okay, which is this formula right here, because at least we have 2 out of the 3 things that we need. So let's rewrite this. Let's say S of n is n over 2 times our first term is right there. That's 12. Plus our last term, our nth term, is right there. That's 180. So let's simplify this. We have n over 2. 12 plus 180 is 192. And then we can simplify that. Becomes 1, and 2 goes into 92, 96 times. So now we have this formula. There's only one problem. We don't know how many terms are in this series right here. Okay, so here's how we can do that. We can go back to that other formula that we used in a prior video, which is telling us a formula for finding the nth term, and it was this right here. It was a sub n. If we want to find any term in this sequence, we can use this formula right here. Alright, so now how do you solve equations with you have variables in it? You need to know all but one variable. And if you look at what they're giving us, they actually give us all of this. We know that our last term is 180. We know that our first term is 12. We know they didn't tell us directly, but we can find out that the common difference here must be 7, because we're going up by 7 each time. And then we don't know n, but we're about to find it right now because we have everything else we need except for n. So let's solve for that. So 180 equals 12 plus 7n minus 7. 12 minus 7 is 5, plus 7n is 180. Let's subtract the 5 from both sides. We would get 175 equals 7n, meaning that n is equal to 25. And that is the only thing that we're missing over here. So that means that term, that sequence, that series that we just dealt with actually has 25 terms, and we can find the sum of the 25 by doing this right here, and that turns out to be 2,400. That's the sum of that series right there.